Hey guys, it's Finn. So in this video, I'm going to implement the evolving stuff in the Neat class. And this is probably going to be one of the last videos. So if you have this one to finish and everything works, basically you got a almost working Neat code with a few exceptions. So let's go in here, and what we did in the last video is we created the clients and the species. So we need a random hash set, or yeah, let's use a random hash set for that. So random hash set of clients, and we want to start the clients. So create a new clients random hash set and a new one for the species as well. So let's call this one species and put species in here. Good. Now the next thing is, when we reset everything, we got an amount of clients that we want to create. So let's go in here, and it's very important that you do a for loop, but not in front of this, but at the end, because well, I had this mistake and I was like, I was struggling to find the mistake, because if you do it in here, you will create some new nodes because of the empty genome thing. But well, it's going to create new nodes, and it's not going to take the input and output nodes, and this would cause the calculator to not realize what's an input and what's an output node. Okay, so in here, I'm going to call public, for int I is equal to 0, I is smaller than the amount of clients that we have. So clients, well, it's actually max clients. So max clients is the amount of clients that we want to have, I++, and then we create a new client. So client C is equal to a new client. We set the genome, so set genome to create empty genome, or just empty genome, and then we add him to our genomes, or to our clients. So clients dot add, it's clients. Okay, we need to use this dot clients dot add, and we add this client. Okay, so the next thing that we need to do is we want to well, actually we should also generate the calculator in here. This is not really needed, but well, we should have it in here. So next thing that we want to have is we want to implement a method for the user at the end to get one specific client to perform some testing, calculations, and whatever, to assign the score and so on. So public client get client by taking the index of the client. So return clients dot get the index. You could also do some additional checking if this index exists and so on, but I'm not doing this right now. Okay, so the next thing that we need is we need a we actually need to clear the clients array as well. So this dot clients dot clear. So if we call reset after we already called this, there might be some clients in here, so just call clients dot clear. Now actually we can go into the evolving part. So let's go above the main method, and in here I'm going to create a new method and call it public void evolve. So I will put the method names in here, and we're going to implement the method one by one. So the first one is we want to generate the species and place our clients in the species. Next thing is we want to kill, let's say, I don't know, 50% of the clients. Then we want to remove those species who've gone extinct. So remove extinct species. Then we want to reproduce the clients that have gone extinct. Then we want to mutate everything, and at the end we want to generate the calculator. So for client C, in clients.getData, we call c.generate calculator. Good. Now let's start with the generate species method, because this is probably the hardest one to implement. So create a new method called gen species, and in here the first thing we need to do is we need to reset all these species. So for species, as in species, we're going to call s.reset, and it's not species, species.getData. Good. Now the next thing is we need to iterate through all the clients, and what we did in here is we reset all the clients except for the representatives. So what we do next is we iterate through all the clients and place them in the corresponding species, except for the representatives because they're already placed in a species. So for client C, in clients.getData, and we need to check if it is already in a species. So if c.getSpecies is not equal to null, we want to continue the for loop and continue with the next client. Otherwise, we are going to check if we can find a new client, a new species. So boolean found is equal to false, and we iterate through all the species and check if we can add it to one, basically when the distance is smaller than our offset. If not, we are going to create a new species. So for species as in species, this species.getData again, and we got the method, put method. So if s.put the client, then this returns true and we added him. If not, we can what we do is we found a species and we can break the loop. Well, if we do not find, we can try this for every, let's say we have 10 species, we try every 10 species, and this always returns false, so we have never added him to any species. Then we can create a new species. So if found is equal to false, or if found, we can call species.add a new species, and the representative is going to be this new client. Good. And the next thing is we need to adjust the scores. So for species as in species.getData, we want to set s dot or we want to evaluate the score. So calculate the average score of the clients so that our species has a score that represents this species. Good. The next thing is, the kill method is actually pretty simple. So let's go in here, call private void kill, and what it does, it's going to kill let's say 50% of the population. So what we need for that is we need a new variable that determines how many are going to be killed. So let's go in here, call private double, and I'm going to call survivor. So I'm going to give the amount of survivors, and let's set it to, let's say 80%. So 20% is going to die and 80% is going to live. Now the problem with that is we want to tell the amount of people that's or the amount of clients that are going to die. So it's like just 1 minus survivors. So in here we iterate through all the all the species again. So I'm just going to copy this one, and I'm going to call s.kill, but the percentage is going to be 1 minus the amount of survivors, like that. Good. The next thing that we want to have is we want to have the remove extinct, not like that, like that. Great method. And okay, so what we do for this is we iterate through all the species, but we need to use an index because we might want to remove some. If you use an for each loop, this is going to crash because you can't remove elements while you iterate over them. So for int I is equal to species.size minus 1, I is greater than 0 or greater and equal to 0, and I is reduced by 1 each time. What we do then is we check if the amount of clients that we have in there, so if species.size is smaller than or equal to 1, so if only the representative is left, we are going to call species.getI.goExtinct, and we call species.remove I. Good. The next thing is we want to have the reproduction method. What we do for this is we create a new method. So we got this new method, and what we do in here is we're going to iterate through all the clients and check if they are basically dead, so they have not a species assigned, and create a new genome and assign this genome to the client. So what we do for this is we need a method to select the species that should reproduce the client. What we need for that, or what we want, is that a species with a higher score has a higher probability to produce a new client. So we need the random selector class that I created in the first video. So random selector of species is going to be a selector is a new random selector, and we're going to add every species to that. So for species as in selector.get not selector but species dot data, get data, we call selector dot add, and we add the species and with their score, like that. Good. Now the next thing is we iterate through all the clients. So for client c and clients dot get data, and we check if it has been killed. So if c dot get species is equal to null, then we are going to choose a random species. So selector dot or species as is equal to selector dot random dot random, and what we do then is we set c dot set genome to s dot breed. So the selected species is going to breed a new genome, and this genome is assigned to the client. Next thing is we want to force this client into the species. So s dot force put this client. For the next method, for the mutate method, we can again create a new method called a public void mutate, and the good thing is we already got the mutate method implemented for one client, so we only need to iterate through all the clients. So for client C, in clients.getData, and we call c.mutate. So this is actually everything that we need for the evolving part, and we're going to check this if everything works. Okay, so I found a few mistakes. So the first one is in the reproduction method, everything worked for this, but this actually caused the problem at the end. So there were no species in there. So for some reason, the remove extinct species removed my only species, and I had 800 clients in here. So, well, it has been removed for some reasons. So I went into the remove extinct species method, and in here I had species.size smaller or equal to 1. And well, we don't want to remove a species when the amount of species that we have is equal to 1 or less. We want to remove it if the size of that species at any given index is smaller or equal to 1. The next thing is that I messed up is in the species method itself. There in the kill method, there was a problem in here. When we removed the percentage of our clients, I had this checking in here. So the problem with that is that the loop is running, and every time it runs, it's going to check how long it has to run. But when we remove data in there, while we check that we want to remove a percentage, it's not going to work, because let's say we remove the first element, and then there were 999 elements left, and then he was like, okay, I need to run to percentage times this.clients.size so I need to run until I get 199. So this didn't work as expected. So it only removed like roughly 170 and not exactly 200 as I expected with my 20%. Good. Now the next thing is that I should have everything working now. So I can go into the main method, and what I did is I created a new double array. For each element or for each value, I assign a random value, and then for every client I set the score to the output. So I've got an input size of 10, the output size of 1, and the score that is assigned to each client is basically it's just the output. So this is a very simple example. What I'm going to do next is I'm going to do this in a for loop. So for in I smaller than 0i smaller than 100 I plus plus, and if I run this in a loop, each time I'm going to calculate the score, and I'm doing the evolving part. And if I do this, hopefully everything should work. And obviously I want to print the that's what I did as well. I implemented a method that prints the species. It's very simple, so it just prints a line, and then I iterate through my species and print the species, the score, and the size of it. So I can check I can get this to get the average score and check if my score is increasing or decreasing or nothing is happening. So let's go back into the main method, and in here call print species of the need object. And if I run this, hopefully we should have some good output. And actually we do. So what you can see here is that we started with a average output of 0.5, and we started very slowly with 1,000 clients. So for many iterations we had only one species, but then suddenly we had lots of different species because the offset, like the distance to the representative, became larger and larger every time we mutated them. So some of them died, and well, they changed actually pretty rapidly, but you can see that at the end, or in the average score, keeps increasing every single time, and at the end we got a pretty nice score. So let's go for 1,000 iterations, and hopefully we should have a pretty nice output. So you can already see that some outputs are very close to 0. So how could we change this? What we could do is, for example, in here I had my mutations very low. Why I did this is so when you increase these, it might happen that you have new species every single time. So basically you would miss the point of actually having a species. You could increase these, but this would result in more species being generated. So you can see that this species is B7 at the end. It also exists here, and the amount of clients does not really change. Well, it changes a little bit. If I would increase these factors, let's say by let's set it to like high percentage values, you could see that it might probably work, but it's going to create new species, and actually the value doesn't really increase. So sometimes we have 0.5 again, so there are just too many mutations, and we're not really getting the optimal value for that. So you can also see that this 2C species does not exist down here anymore. So this is definitely not what we want. So let me check. Let me put this back to small percentage values, and if I run this again, hopefully we should have some nice species again. So the next thing that I'm going to do is, in the next video, someone told me, and well, I also told you that when I made the video, that when we remove a connection and replace it with two connections and a node in between, that we always create a new node in the middle with a new innovation number and two new connections. And he said, well, yeah, like someone in the comments said, yeah, that you could do that, but that's actually missing the point of need, and he's probably correct. So we did this for simplicity, but I'm going to fix that in the next video. And well, basically this code is working and it looks pretty nice. So what we could also do for now is we could go in here and create a new frame and not get the empty genome, but need.get client at let's get the first client and look how he looks. So get genome in there, and we're going to do the evolving part again, and at the end we should have a so this is basically the output, and I see that there's a problem because this node should not exist at all. So I'll take a look why this is happening. So this was already it for this video. So I have to see you in the next video.